In Meteorologica, Aristotle, 384–322 BC, states that the Greek philosophers Anaxagoras, c. U 200–9500–428 BC, and Democritus, 460–370 BC, proposed that the Milky Way is the glow of stars not directly visible due to Earth's shadow, while other stars receive their light from the Sun, but have their glow obscured by solar rays. Aristotle himself believed that the Milky Way was part of the Earth's upper atmosphere, along with the stars, and that it was a byproduct of stars burning that did not dissipate because of its outermost location in the atmosphere, composing its great circle. He also said that the milky appearance of the Milky Way galaxy is due to the refraction of the Earth's atmosphere. The Neoplatonist philosopher Olympiodorus the Younger, c. U 200–949–570 AD, criticized this view, arguing that if the Milky Way were sublunary, it should appear different at different times and places on Earth, and that it should have parallax, which it does not. In his view, the Milky Way is celestial. This idea would be influential later in the Muslim world. The Persian astronomer al-Biruni, 973–1048, proposed that the Milky Way is a collection of countless fragments of the nature of nebulous stars. The Andalusian astronomer Avempais, d. 1138, proposed the Milky Way to be made up of many stars but appears to be a continuous image in the Earth's atmosphere, citing his observation of a conjunction of Jupiter and Mars in 1106 or 1107 as evidence. The Persian astronomer Nasir al-Din al-Tusi, 1201–1274, in his Tadkira wrote, "The Milky Way, i.e., the galaxy, is made up of a very large number of small, tightly clustered stars, which, on account of their concentration and smallness, seem to be cloudy patches. Because of this, it was likened to milk in color." Ibn Qayyim al-Jawziyya, 1292–1350, proposed that the Milky Way is a myriad of tiny stars packed together in the sphere of the fixed stars. Proof of the Milky Way consisting of many stars came in 1610 when Galileo Galilei used a telescope to study the Milky Way and discovered that it is composed of a huge number of faint stars. Galileo also concluded that the appearance of the Milky Way was due to refraction of the Earth's atmosphere. In a treatise in 1755, Immanuel Kant, drawing on earlier work by Thomas Wright, speculated, correctly, that the Milky Way might be a rotating body of a huge number of stars, held together by gravitational forces akin to the solar system but on much larger scales. The resulting disk of stars would be seen as a band on the sky from our perspective inside the disk. Wright and Kant also conjectured that some of the nebulae visible in the night sky might be separate galaxies themselves, similar to our own. Kant referred to both the Milky Way and the extragalactic nebulae as island universes, a term still current up to the 1930s. The first attempt to describe the shape of the Milky Way and the position of the Sun within it was carried out by William Herschel in 1785 by carefully counting the number of stars in different regions of the visible sky. He produced a diagram of the shape of the Milky Way with the solar system close to the center. In 1845, Lord Rosse constructed a new telescope and was able to distinguish between elliptical and spiral-shaped nebulae. He also managed to make out individual point sources in some of these nebulae, lending credence to Kant's earlier conjecture. In 1904, studying the proper motions of stars, Jacobus Kapteyn reported that these were not random, as it was believed in that time. Stars could be divided into two streams, moving in nearly opposite directions. It was later realized that Kapteyn's data had been the first evidence of the rotation of our galaxy. which ultimately led to the finding of galactic rotation by Bertil Lindblad and Jan Oort. In 1917, Heber Curtis had observed the nova S Andromedae within the Great Andromeda Nebula. Messier Object 31. Searching the photographic record, he found 11 more novae. Curtis noticed that these novae were, on average, 10 magnitudes fainter than those that occurred within the Milky Way. As a result, he was able to come up with a distance estimate of 150,000 parsecs. He became a proponent of the island universes hypothesis, which held that the spiral nebulae were independent galaxies. In 1920, the great debate took place between Harlow, Shapley and Heber Curtis concerning the nature of the Milky Way, spiral nebulae, and the dimensions of the universe. To support his claim that the Great Andromeda Nebula is an external galaxy, Curtis noted the appearance of dark lanes resembling the dust clouds in the Milky Way, as well as the significant Doppler shift. The controversy was conclusively settled by Edwin Hubble in the early 1920s using the Mount Wilson Observatory 2.5 meters, 100 in, Hooker telescope. With the light-gathering power of this new telescope, he was able to produce astronomical photographs that resolved the outer parts of some spiral nebulae as collections of individual stars. He was also able to identify some Cepheid variables that he could use as a benchmark to estimate the distance to the nebulae. He found that the Andromeda Nebula is 275,000 parsecs from the Sun, far too distant to be part of the Milky Way.